Welcome to week 7, question 6. We're looking at extrema of exponential functions. So in the last few questions we've been working on sum and difference and power rule. So this one now takes us into exponential functions. The question reads, the number of hourly hits in thousands on a company's website, X hours after a certain news story breaks, can be approximated by this function h at x. Find the locations of all local extrema and the value of the function at each of those extrema. Okay, so again, we've defined it as an exponential function, or it has been defined for us. And so we're looking at exponential rule for finding derivative. So we have e to the ax, and the derivative is ae to the ax. So we're going to put that aside to remind us. What else do we have? We have a constant here. We need to look really carefully at this term here because it's not simply an exponential function, but in fact if we look really closely we're going to see that it's actually a product. It's a product of 30x times e to the negative 0.5x. So what we're going to have to do is apply power rule for 30x. We're going to have to apply exponential rule for e to the negative 0.5x, but because they're combined in a product, we're also going to have to use the product rule. Okay. So the first thing we should do is write down the product rule so we know what we're dealing with. So remember that any function that has a u times a v, is the derivative of that is going to be just the u times the derivative of v plus v times the derivative of u. So what I'm going to suggest is that we define our u and v in this function we're given, h at x, take the derivative, and then we're going to be able to put those values back into the equation. So we're going to define u as 30x, and u prime, the derivative using the power rule, is simply 30. We're going to define v as e to the negative 0.5x, and v prime will be negative 0.5 e to the negative 0.5x. Okay, so now if we put all of those back into our product rule for this function, we're going to have h prime at x is going to equal, okay, we've got u, 30x, times v prime, which is negative 0.5 e to the negative 0.5x, plus v, which is e to the negative 0.5x, look like a 5, times u prime, which is 30. Okay, so our order of operations rule would say that we're going to be doing the multiplication first. So let me just multiply those together here. And that would equal negative 15x e to the negative 0.5x plus 30 times e to the negative 0.5x. We can see if we look closely at this function, we've got this factor in common. So I'm going to suggest we factor that out and see what we're left with. So I'm going to say 30 minus 15x and multiply by e to the negative 0.5x. Okay. So I've rewritten our derivative function here, and I think at this point we should really reestablish what we're looking at, what our goals are. And remember that we're trying to find the local extrema and then the value of the function at each of those extrema points. So again, to find the extrema, we're looking at where the slope of the derivative equals 0. So we would need to set h prime at x equal to 0. So I want you to think about your past math. When you have a multiplication, such as we do here, this times this, in order for that product to equal 0, either one piece of the product has to equal 0, or the other part of that product has to equal 0. So if we look at setting e to the negative 0.5x equal to 0 and solving for x, we find very quickly, because we have to take the ln of both sides in order to isolate that x, that we have a ln of 0 on the one side. And if you put that in your calculator, or if you recall, ln of 0 is undefined. So we need to be looking at this second part of the product. So we can say 30 minus 15x then must equal to 0. 30 equals 15x, and x must equal 2. 30 divided by 15. So this means at 2 hours we have either a max or a min. So we can assume, or we would hope, that it would be a maximum point, given that you've released a certain news story and you're hoping that the hourly hits will be at a high, a maximum. But we should test the points just to be sure. So let's look at if we have x equal to 0, and we're putting that into our derivative function, so x prime at 0, we find that that is 30, so that is greater than 0. And if we substitute 3, which is a number after 2, into the derivative function, we find out that's negative 3.35, so that's less than 0. So you can see that we are, in fact, at a maximum point at 2, because the slope is going from positive through 2 at 0 slope and down. So we've got a maximum at 2. The next thing we need to do, it says find the value of the function at each extremum. So we're now going to substitute 2 into the original function to find out the number of hits. And if we solve that, we're going to find out that it is 23.073. And remember that the question talked about hourly hits in thousands, so we need to make sure we write 1,000. Yeah? There you are.